Hello and welcome back to e-sipnayan. For today's video, we are going to discuss how to solve the parts of a parabola. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. For this video, the learning objective is that at the end, you should be able to solve the parts of a parabola using formula. Now let's first try to identify the relationship between the movement along the x and y axis and their corresponding operation. So the operations can either be add or subtract. So if we are going to plot points and the movement is along the x-axis, or there is a horizontal movement, or the movement will be to the left and to the right, we can associate h and k as the x and y. So if there is a horizontal movement along the x-axis, it is the value of h that will become modified and then k will stay the same. So if the movement is to the left, we are going to subtract to h. If the movement is going to the right, we are going to add. So definitely if there is a movement to the left, it is subtraction. If it is a movement to the right, that will be addition. And where are we going to add or subtract? Given the vertex, we are going to add or subtract to h because h corresponds to x and x is also pertained to as the one identified along the x-axis. How about if the movement is along the y-axis? So we associated a while ago h and k as x and y. So k this time is associated with y. And y is the value found vertically along the y-axis. Therefore, if there is a vertical movement or the points moved upward and downward, if it is going downwards, we are going to subtract by k. And then if it is upward, we are going to add. So the direction downward will be related to the operation subtraction and upward will be related to the operation addition. So just in case there will be movements along the y-axis or vertical movements either downward or upward, the value of the vertex that will be modified will be for variable k. Let's now proceed to the formulas. First is the formula for the focus. So in this table, shown is the orientation, the standard equation, and the formula to get the focus. So notice that in identifying the value of the focus, we are adding or subtracting either to h or k, and then the value that we're going to add or subtract would be the value of p, similar as to how we are graphing. Let's now have the first example. Y minus 4 squared equals 8 times x minus 1. We'll be determining first the opening of this parabola, and this is a parabola that opens to the right. Therefore, what we're going to use is h plus p k. So the opening of this parabola is a parabola that opens to the right. The vertex is identified as 1, 4. Now, why do we need to determine the vertex? Because the formula to find the focus will involve variables h and k. And aside from that, we need the value of p. So, to identify the focus of this parabola that opens to the right, we are going to follow h plus p k. Now, where did we get h plus p k? Say for example, we plot here a parabola that opens to the right. The vertex is plotted on the leftmost side of the curve and the focus will be plotted to its right. Now from vertex to focus, there is a horizontal movement or a movement along the x-axis and that is going towards the right. So definitely we're going to add. And where are we going to add? We're going to add with h because h is associated as x and the movement is along the x-axis. Now let's identify the values of h, k, and p. So h is 1, k is 4, and the value of p for p is identified as 8. Therefore, p is equal to 2. After that, we simply substitute the values. So h is 1 here plus p, which is 2. And then simply copy k. Then after that, simplify. The focus will now be plotted at 3, 4. Moving on to the next example, let's identify the orientation. And this is a parabola that opens to the left. Therefore, this is the formula that we are going to use. The vertex is at -3, +1. So definitely the focus will be using the formula h minus pk. Now let's try to illustrate a parabola that opens to the left. The vertex will be found on the rightmost side of the curve. And to plot the focus, that will be to the left of the vertex. Now, since the movement is going to the left, the operation associated to that is subtraction. And we're going to subtract, of course, with h again because the movement is along the x-axis. And the one associated with x is h. So let's identify the values of h, k, and p. H is -3, k is +1, and p is equal to 4. Now, for p here is identified as -16, so p is equal to +4. After that, simply substitute the values. H is -3 minus p is 4, and then k is equal to 1. Substituting further, the focus will be found at -7, +1. Moving on to the third example, the opening of this parabola is upward. So the vertex is at -7, -1. Since this is upwards, the formula for the focus is h, k plus p. So let's try to illustrate a parabola that opens upward. The vertex will be on the lowest point of the curve. And to plot the focus, we're going to move upwards. So since we moved upwards, the operation associated with that is addition. And then since it is a vertical movement, we are going now to add p to k instead of h because k is the variable related to y. After that, let's substitute the values of h, k, and p. So h is -7, k is -1, p is 3 because 4p is 12. So substitute the values h, copy h, k is -1, then we're going to add p. Simplifying that, we'll have now the focus at -7, +2. Next example, this is a parabola that opens downward. So the vertex will be plotted at 1, 0. So since this is a parabola that opens downward, the focus will be using the formula h, k minus p. Now let's try again to illustrate a parabola that opens downward. The vertex will be at the highest point, and the focus will be plotted below the vertex, which is somewhere here. So since the movement is downward, the operation associated to that is subtraction. And since the movement is along the y-axis, it is k where we are going to subtract. Because again, k is the one associated with variable y. Now let's identify h, k, and p. H is 1, k is 0, and p is +1 because 4p is -4. Now we substitute the values. Simply copy h, comma, k, and then minus p. After that, we substitute, we simplify. The focus will now be at 1, -1. Next part would be the directrix, and basically there will be just two options. It can either be an equation which is using variable x or an equation using variable y. Now if we use x, it will be a parabola that opens to the right and the left. Why x? Because x represents a vertical line. So the directrix of a parabola that opens to the right and to the left will be a vertical line. Therefore, we're going to use the equation as x. Meanwhile, if the parabola opens upward or downward, notice that the variable used is y, because y represents a horizontal line. So if it is a parabola that opens upward or downward, the directrix will always be a horizontal line. Now, why are we subtracting or adding with p? It's because that will be the number of units to plot the directrix. Let's now have the first example. This parabola opens to the right. The vertex is at 2, 1. And then the formula for the directrix will be x equals h minus p. Now again, let's try to illustrate a parabola that opens to the right. The vertex is plotted here on the leftmost side of the curve. And to plot the directrix, it will be on the opposite direction, which is going towards the left. So the directrix will be a vertical line. That's why we're using x. And then y minus p, because the movement to plot the directrix is to the left, so that is associated with subtraction. And then how many units will we move? from the vertex to the directrix, that will be the value of P. So we now substitute the values of H, K, and P. H is 2, K is 1, P is 2. For P here can be identified as 8. So divide that by 4, you get P, which is 2. So we now substitute the values, copy H equals, the value of H is 2. The value of P is also 2. So simplifying that, the equation will now be x equals 0. Next example, we have a parabola that opens downward and the vertex is at 1, 0. So definitely, the formula for the directrix is y equals k plus p. Let's try again to represent a parabola that opens downward. So the vertex will be found on the uppermost part of the curve. And then to plot the directrix, it will be the opposite direction, which is upwards. And then the number of units will be p. That's why the formula is using y variable, because the directrix is a horizontal line. And then we are adding to k because it is a vertical movement, and k is associated with y. Next, yp, because p is the number of units that we need to take note before we plot either the focus or the directrix. Now let's identify the values of h, k, and p. H is 1, k is 0, p is 4. So that will be, let's substitute the values, copy x equals, k is 0, and then p is 4. So simplifying that, we'll have x equals 4. Let's now have the equation for the axis of symmetry. Notice that it is almost the same as the formula for the directrix, but this time it will just be y equals k or x equals h. Now, if it is a parabola that opens to the right or to the left, the axis of symmetry obviously will be a horizontal line. That's why the variable that is used is y. Meanwhile, if the parabola opens upward or downward, the axis of symmetry will always be a vertical line. That's why the variable used here is x. Let's have this example. The opening is to the left. The vertex is at -2, +1. So the axis of symmetry will be represented as y equals k. So simply identify what is h and what is k, and that will give us a formula y equals 1. Because y is the variable used and the value of k here is 1. Therefore, the axis of symmetry is y equals 1. Moving on, we have this equation, and the opening is that it's a parabola that opens upward. The vertex is plotted at the origin 0, 0. So the formula for the axis of symmetry is x equals h. Now we substitute the values h, k, and p. So h is 0, k is 0, p is 3. Therefore, the axis of symmetry is x equals h or x equals 0. Next, let's solve for the endpoints of the lattice rectum. Given this formula, take note that there will always be 2 endpoints of lattice rectum. Therefore, per opening, there will also be 2 different formulas. So a parabola that opens to the right will have this formula, h plus p, comma, k plus 2p, then h plus p, comma, k minus 2p. So notice that the variables that you're seeing here are h, k, p, and 2p. So why do we have here the value of p? Remember that the endpoints of the lattice rectum will be plotted starting from the focus. That's why what you're seeing here as the addition and subtraction of p will be the one that will help us align the endpoints of the lattice rectum with the focus. And then obviously 2p is the movement from the focus to one of the endpoints of the lattice rectum. So let's now have an example. This is a parabola that opens to the right. The vertex is at 0, 1. So to plot the endpoints of the lattice rectum, that will be using this formula. So let's try to illustrate here a parabola that opens to the right and how were we able to obtain the formula. So the vertex is here, focus is to the right, then the endpoints of the lattice rectum is above and below the focus. So to plot LR sub 1, the formula is h plus p, then k plus 2p. Now we added 2h, and that is a movement horizontally. So from the vertex, we move to the right. That's why we have the equation h plus p, both to LR sub 1 and LR sub 2. Next, we have k plus or minus 2p, because after we move to the right, we need to plot the endpoints of the lattice rectum whose movements would be upward and downward. So if we moved upward, that is representation of plus 2p. If we move downward, that is the representation of minus 2p. So take note, class, that whenever there is a movement horizontally, we are going to add or subtract to h, which is the case. But if the movement is vertically, we're going to add and subtract to k, just like in this given example. And that is how we obtained the formula for the endpoints of the latus rectum. Lastly, p, of course, is the number of units from V to F, and then 2p is the number of units from F to LR sub 1 and LR sub 2. Let's now identify the values of h, k, and p. H is 0, k is 1, p is 2, because for p here is 8. Let's now substitute the values for LR sub 1 and LR sub 2. So h is 0, p is 2, k is also 0, copy 2, that is a constant multiple, and then substitute p again as 2. Do the same for LR sub 2, substitute h, p, k, and for 2p. Then after that, simplify. Therefore, the endpoints of the latus rectum will be plotted at 2, 4, and 2, negative 3. Next example, this is a parabola that opens downward. The vertex is at 2, 7. So the formula that we are going to use is this one. The values of h, k, and p is 2 and 7. Let's try to illustrate here a parabola that opens downward. And then let's make sense of the formula constructed. The vertex will be at the highest peak of the curve. So the focus will be plotted below the vertex, and the endpoints of the latus rectum will be plotted to the left and to the right of the focus. Now notice that there is a downward movement from the vertex to the focus, and that will be p units. So since there is a vertical movement and that is downward, we're going to subtract by k, which is the same as the formula. Next, from the focus, we moved to the right and to the left, and that will be 2 units each. So since it is a horizontal movement, we're going to modify the value of h. So we're going to add 2p to h if we move to the right, and we're going to subtract 2p to h if we moved to the left. So let's now substitute the values for LR sub 1 and LR sub 2. So substitute h, the value of p, and k. Do that twice for LR sub 1 and LR sub 2. Then simplify. So the endpoints of the latus rectum given the equation is 4, 6, and 0, 6. And that will be the end of this video. I hope that at this point you were able to use the formula to solve for the parts of a parabola. And that is all for this video. See you again on the next one. Bye!